So this is a table summarizing again how a curve could look and the relationship between the first, second derivative and the original function. So if my first derivative is positive and my second derivative is positive, it looks like this graph. So my function is increasing and it would be concave up. It's increasing because the first derivative is positive. It's concave up because the second derivative is positive. If my first derivative is positive and my second derivative is negative, what we know is that because the first derivative is positive, my function is increasing. And because the second derivative is negative, my function is concave down. So it would look like this at this point A. It would be increasing and concave down. The third case we could have is that the second derivative is negative, sorry, the first derivative is negative and the second derivative is positive. So the first derivative negative implies that f of x is decreasing, so my function is going down. And the second derivative positive is that my function is concave up, so it's curved upward. So it would look like this at this point A. And then the last case is that both are negative. So if my first derivative is negative, f of x is decreasing, so it's going down. And if my second derivative is negative, f of x is concave down, so it's curved down. Okay, so this is the four cases of what a graph could look like at a point based on the first and second derivative. So we can also make sign charts of the second derivative. And the sign chart of the second derivative helps us figure out concavity. So what we're going to do is we would have the same thing, but instead of writing f prime, we would write f double prime. And instead of putting increasing and decreasing, we put concave up and concave down for what is happening at f of x, because the second derivative always tells me concavity. So a sign chart of the second derivative, how we would do this is we would have our intervals for x, and then they would say where f double prime is negative and positive, and where are the possible point of inflections, which is where the derivative, the second derivative is equal to 0. So from negative infinity to negative 5, the second derivative is negative, and so f of x would then be concave down anytime it's negative. At negative 5 to 4, my second derivative is positive, so it's concave up. And then at negative 5, if my function changes from concave down to concave up or changes concavity, that is called a point of inflection. So this is a PI for point of inflection because the second derivative changed sign. So then I look from 4 to 8, the second derivative is positive, and so I'm still concave up. And so at x equals 4, this is neither. This is not a point of inflection, okay? So you could put none, NA, something like that to indicate this is not a point of inflection because the concavity did not change, because the second derivative did not change sign. And then at 8, to figure that out, we have to look at 8 to infinity. That's negative, so it went to concave down. And because the second derivative changed sign and the original function changed concavity, this would be a point of inflection. And so a point of inflection is both when it changes from concave up to concave down or from concave down to concave up. So that is a second derivative sign chart. And we can draw it for a graph as well. So we're going to use this graph again, but now we're going to make a second derivative sign chart. So to do that, we do the same thing. We find, in this case, we find where the points of inflection are. Okay, so we're going to kind of guess that because we don't know exactly without an equation, but we know that from -3, it's definitely concave up, it's curved upward, it's curved upward. And then somewhere around here, it changes. I would say at -1, you can make it a point that it's somewhere between -1.5 and -1. So I'm going to just pick -1 because that's an easier number to deal with. And then it's concave down everywhere else. So my intervals for my sign chart are from -3, because I have an endpoint, to -1. -1 is, again, that possible point of inflection. In this case, it's our point of inflection. And then from -1 to 1, because my graph starts at 1, is my third interval. Okay, and then I'm gonna put f double prime and then f, because I'm showing the relationship between the second derivative. Okay, so from f double, I'm gonna fill in f because it's easier to see with the graph, but f is concave up from -3 to -1, which means the second derivative is positive. Okay, you can either put a plus sign or put positive. At -1, the second derivative is going to be 0 because this is a point of inflection. And from -1 to 1, my function is concave down, it's curved downwards. And so the first derivative is negative. And so that is my second derivative sign chart. And again, you can also do the number line, like I said, for the first derivative, where you would put the point of inflection, you would put that the second derivative is positive, so it's concave up, negative, concave down, it's 0 here, and this is a point of inflection. And then I should put my endpoints that I have. So that's another way to draw the sign chart. Okay, so that's the second derivative sign chart.